Welcome to BOCES, Broome-Tioga BOCES manufacturing program. The picture you see here is one of our 3D printers printing a handle for something. I will show you in a little bit after we get through this first part here. So welcome to manufacturing. Our students enjoy the challenge here. They love to work on hands-on projects. And here's just a short, brief summary of what they worked on. Doing some tapping, some measuring, and some filing, deburring. Just some of the projects they worked on. Rules and procedures. These are pretty common for most classes. They vary a little bit here, but basically we want our students to be safe and not have any accidents. Very important in the shop facility. So the education, career and technical education courses, they're morning and afternoon, and students can ride the bus here or provide their own transportation, or family can provide. You receive 3 credits for every year that you successfully pass your CT class, totaling 6 or 2 years basically. So you have a 2-year course. So a little bit about the teacher. So I'm, again, Jim Mordell. I went to Binghamton University, a Bachelor in Science Mechanical Engineering. I've been in industry most of my career, over 30 years in applications and design, manufacture, industrial engineering and equipment. Areas of expertise include mechanical engineering, prototyping, material application, instruction, mentoring, safety, and drafting. I'm also a former business owner, entrepreneur, so I do have a very good knowledge of what it takes to meet payroll every month at a company. Some of the certificates and memberships I have and belong to are SolidWorks certificate. I have ISO auditor, you may have heard of ISO 9000. I'm an internal auditor. I've been trained in that. Six Sigma green belt. So I know some of the Six Sigma things about quality control. I'm been a member of ASME for many years, and a member of API, which is the American Petroleum Institute, which is who basically sets the tone for the oil and gas industry, which I spent many years producing oil and gas equipment, compressors and turbines. So a little bit about our program. So the first year for the juniors, we start out with safety. And we have basically safety and measurement. They're kind of contained in the same topic. So safety, measurement, safety practices. And we look at effects of technology. What's the history of technology? I'd like to say we start with the Industrial Revolution, but we actually go back into ancient Greece and talk a little bit about some of the technology that was there that's been rediscovered in the last few hundred years. We talk about manufacturing technologies themselves. We look at technical documents as well as how to create technical documents. Also, the geometric tolerancing is part of that topic as well. Basic technological system models, control systems. We look at properties of systems. Career opportunities. We intersperse career opportunities with most of the topics. Design principles. Students will learn about engineering design process and mass production systems, and learn about robotics. And in lab, they will be introduced to shop equipment, safety, and safe operation of all equipment that they touch before they touch it. And by the way, I would not let a student work on a piece of equipment they've not been qualified on. So by qualified, I mean they have to show me, they have to watch my demonstration and show me they can operate it safely. And then once we get done with that one-to-one, I don't want to call it a certification. It's not really a certification, but that one-on-one preparation, then they're allowed to use the tools. And we have hands-on industry projects, which are basic type of projects, but they're work-based learning. So they obtain credit for all the projects they work on that are out from outside of the classroom. And we plan on having guest speakers as soon as possible. We've had a couple guest speakers already on Zoom meetings, but we would love to start having them come in real life, and that may be happening soon. So the second year is a little different. I'll put it this way. They learn all the things in the first year, they apply to the second year. So the second year, they'll be reviewing and reinforcing all the topics from the first year. Then they're going to develop work readiness skills. And probably should spell that correctly. With an emphasis on their work-based learning, free enterprise and marketing. Assessment testing will happen during the second year, and students will be guided to tackle more advanced industry projects, and they'll be lab focused. So they'll be lab focused, so they'll be working in here and possibly, hopefully, at an offsite company too. So we have, sorry about that. We have trade committee representation throughout the year. Members of our staff and I meet with people who are working in the industry to make sure that our classes are teaching and syncing with the information skills that future employers are looking for an employee. One example, we do a lot of work with, we've done a lot of work with Raymond Corporation up in Green. They've been very supportive and vocal in their wants and needs, and we appreciate that definitely. We want companies to, advocate for what they need so that we can fulfill that. Advisory committee during this school year of 2020-2021. We've had 2 meetings with the members of our trade committee. Again, like I said before, this provides us with a lot of guidance and direction that we might or might not have. And it's always better, I say this, it's always better not to have to guess, but to talk to somebody and find out what they really need. And that's what we do. I do, part of my job is bridging that gap from academia to industry. And I've talked to so many people in industry over my career, been in industry, I understand it. So hopefully that's a big part of what I can help the students with, to appreciate how to be able to do that without much, do it seamlessly without much worry and fuss. So. Okay, employability profile. So twice a year, work skills employability profile documentation is updated at least twice a year, probably a little bit. I get in there and update it a little bit more as I see improvement with the students, but for the most part, twice a year. And this document can be used by the students for entry into post-secondary education programs, military service, employment opportunities. Basically, it's something they can take with them as part of their portfolio, which they'll be working on a portfolio, resumes, cover letters, that they can take with them into an interview and show an employer. This is my rating. I'm employable because. So that's what we hope to do. Integrated credit. This course integrates New York State learning standards for English language arts, or ELA, math, and science. Should really say and science, so that it can fit all the classes in your homeschool. And then for any credit options, I recommend you talk to your school counselor specifically, and also to apply to be inducted into this class. You need to talk to the school counselor at your home district, whether it be Shingle Forks or SV or Vestal, wherever it is. And they have to be the ones to initiate your child coming into this program. So can't emphasize that enough. Integrated credit. So integrated credit, these are things like research projects, writing assignments, use of math or science to solve problems, expand your comfort. These are used to expand their comfort zone, learn ways to align your work ethic with industry. That's very, very important, and increase awareness of personal and group safety. So that's kind of how it works, and what it what it is, but how it works is we practice. Students practice, and they do by trying and learning, and do jobs by hand, hand-eye coordination, and everything else that goes with that. So the Skills USA part is a national organization, and we encourage students, you can read this, encourage students to join this and participate. It's very good, and there are scholarships that are associated with Skills USA. If any of you are familiar with Mike Rowe on Dirty Jobs on TV, Mike Rowe is what amounts to our spokesman for both CTE, which is Career Technical Education, and Skills USA. He's a huge proponent of these things. And I think because you're here listening to this, you'll probably agree that it's very important. So, articulation agreements. Articulation agreement is basically an agreement between a college and this class, or any class in CT, where students can receive college credit based on the coursework they complete. So currently we have four main, there's actually probably, I think there's probably more now that have been added since this video, or since this was updated about a month ago. But Mohawk Valley Community College, SUNY Corning, SUNY Canton, and Suffolk County Community College are the four colleges we have right now. And that's really good for a brand new program. But we have to meet certain criteria to get the college credit, and the students have to meet that criteria in their studies and their work. But basically, all my students this semester are well on track to do that. So we're not raising the bar so high that nobody can reach it, but the bar is high. It's just not so high that no students can reach it, and they will achieve their goals and be able to go on to these institutions or obtain jobs or other types of employment through military or any other way they see fit. So these students are well on their way to success already. Certifications, NC3 precision measuring, instrument training, that's coming up. And then we're also looking at trying to do OSHA 10 general manufacturing. That's a very hard certification to obtain. So we're still working on that, but the NC3 seems obtainable, and that should be starting later on in the semester, or we may push that into next year, depending. A lot of our certifications and assessments are done in the second year, so we can do any of these next year, or this year we might do this one, depending. That's up for to be determined. So placement opportunities, again, local industry, manufacturing partners. These are we have a lot of them, even though the job market right now is kind of lean. It's not that lean. There are companies out there, many companies out there that, regardless of what the numbers say, they need people, they need qualified people, and that's our aim, is to send them qualified students. That's our goal here. So U.S. military, that's another one that's branches of the military could be good, good opportunity. Speaking as somebody that's had military people in my family that have gotten very good educations through the military and have very good careers now, and friends of my family and so forth, I can't stress enough that that's a good platform to learn some very good skills, and that would, where our skills here would transfer to that. College, including BCC, or Broome Community College, the old Broome Community College, which is SUNY Broome now. They have an advanced manufacturing program. I'm going to make a correction here too. SUNY Broome. BCC is the old name for it. And I will save this. And some students might want to start their own businesses too. That's yet another possibility as well. So these are all possibilities. It's not limited to these possibilities alone. There could be combinations of things as well. But by the time they leave my class, they should be ready to go into any of these without any problem whatsoever. So I have a time for questions. In lieu of questions, since we're not live, if you have questions, you can reach me at my email, which is jmordell@btboces.org. So thank you for coming, and I'm gonna show you now. This is the end of the canned part of the presentation. I'm gonna show you a live thing that we've been working on here in a moment. So if you bear with me, that shouldn't take very long at all. But if you're interested in BOCES next year, please, as I mentioned earlier, speak to your school counselor as soon as possible. Classes do tend to fill up quickly. So I'm going to stop this presentation now, and I'm going to go to my other presentation, which is prototyping. Now, this is something live that the students have been working on for since the end of October, basically. So most of the year they've been working on this so far. So prototyping from start to finish. And what follows is a photo journal prepared by the manufacturing teacher and the students, gathering each step in the process from initial query to the final product. Now, we haven't issued the final product yet, but I'll take you as far as this goes. So the next slide is the prosthetic hook device, or we call it the PhD for short. And in engineering and manufacturing, people always shorten things and shorthand stuff. And I worked for GE at one time, and that is all we did there. So I try not to confuse the students, but it's a thing that you do in manufacturing so that you don't spend a lot of time explaining things to people. So my students right now are Jacob Hurlbert, Jason Padrazil, Anthony Ellis Skinner, and Eldon Servofsky. And these are the schools they're from. So these are the students right now working on this device. So step one was we get the inquiry. What is the problem? Who wants it? That's the beginning of this. Then we do some critical thinking about what are the variables involved in this. This thing basically was a hook that a handicapped student can use to reach for clothes in the laundry. There's some students that are taught how to work in the laundry here. The students taught to work on all sorts of trades, but that's one where they came to us and asked us, can we help? They had a tool and it broke, and they didn't really like the tool, so they wanted a new design. So we looked at the old design, which were just a couple of pictures, and talked to the teacher, and we started, students started looking at what is critical about this. And they said weight and balance are critical, which were some pretty good assessments on their part. Then we did some prototyping. I'm going to go through these quickly because this could take a long time if I don't. We bent a piece of brass rod. We had a piece of brass rod. It was fairly light, but not as light as we wanted. But we just said, let's make the thing, let's bend up a mock-up of this just to see how unwieldy it is, because the pictures really weren't doing it justice. So we did that. And then we said, well, okay, that thing's way too heavy and cumbersome. So then we started looking at how to meet weight and balance criteria. So students, we took a shot of our whiteboard. We started doing prototyping, writing, just brainstorming prototyping and talking about what we need to do and defining, what we need to look at here. And we started to come up with ideas, and we had a carbon graphite hunting arrow mentioned, very strong, very light. Consider using aluminum for the hook. Consider connecting the hook and the shaft somehow, and we thought about some ways to connect them. And then we said, let's do more testing. So now we got this broken down to essentially 3 parts, but we haven't really said that yet: the handle, the hook, and the shaft. So the next step was one of the students, actually two of the students, decided to start looking at what the handle might look like. And they started looking at the handle, and this is one initial design they came up with, where you slide your hand into this thing and grab this handle here, and the shaft to be attached to the bottom through a hole or clip or something. So that was the first pass. And then we looked at how to get the hook onto the shaft. This is the arrow, and we have a threaded insert. Threaded insert could be anything, but in this case, it was one of the arrowheads. So we started looking at that and thinking, well, we can thread this thing, or we can maybe weld a piece on to here. We started just experimenting. The kids weren't sure. So we said, well, look, we knew that we pretty much knew that aluminum might be difficult to weld or braze to steel, but we only had a steel threaded insert piece. So we started looking at that to see what we could do. And then the class had another design. As we were doing that, we had to design another design meeting, and we talked about sort of gather our thoughts again. And we came up with, the last thing we talked about was the three main parts. And that's where we wanted to break off and somebody focus on the hook, shaft, and handle. So we broke off there. And then here's a result of a test, a welding and a brazing test, or soldering test, I should say. They both failed. And on the dates they failed. So we did that testing, found they failed. We said, okay, then probably the best thing to do is take an aluminum hook and just make a piece of it, bend a piece of aluminum, and then thread the end of it, which we could do because we have drills and we have drill and tap sets here, tap and die sets here, so we can do that. So we're just seeing what else we could do instead. But in other words, if we decided to do something instead of tapping that, then we probably would have had a lesson on tapping for something else. But this became part of the lesson. So failed both the welding and the soldering. That was okay. So the next thing is another student was working on a handle design, and he started out with, this is what he started out with, was he drew a CAD, these are drawn in CAD, by the way, they drew a CAD drawing. And the other one I showed you earlier was a CAD drawing also, and it was, we take the CAD drawings and translate them immediately onto our 3D printers, and we can print them out. So he came up with this design. He worked on it. He's been working on it for a little while. This is back in December. He's been working on and off on some other things as well. So anyway, in December, the second student presented this piece, which is based on that first prototype I showed you earlier, but this was more refined. He's refined it through use of CAD and through the use of 3D printed models to test them and to find out if they are reliable and or comfortable. And this one actually got very good reviews from the teacher. We showed this one to her. This was actually after Jason came back from showing this to the teacher. He was all smiles. You can't quite see that with his mask, but he was pretty happy. So that design has been approved, but we still have 3 other students working on it. So we were looking at some other designs as well. So another student came up with this design. He made a model, and don't worry about this fuzz on here. This is just material that comes off. This is just waste material on here. It needs to be scraped off, but he came up with this type of a handle. And if you can see here, he actually offset it. So this is actually a right-handed handle, which the one before that was a unidirectional handle. So this student took a little different approach, and he's working on modifying his sleeve as well. The handle actually is pretty much set. That's actually a very comfortable handle to use. So he's working on removing some material so you don't poke yourself with the sleeve. And actually, what he drew up and his final design looks like this, where he realized you need some support back here against your forearm when this thing is being tilted, but you also have a good grip on this from the right-handed view. And he can also make this a left-handed model as well. So that's as far as we've gone right now. We've got a couple more, we've got some more photos and things I haven't added, But this shows you, I wanted to show you, this is the kind of work your students can be doing, where they'll be actually working on a problem and solving it and using our tools here in this room to help them solve them, and also using math and science skills as well. And I teach them, I give them little short courses in algebra and trigonometry for certain things that they need. But we also, I mentioned, or I didn't mention this, but we don't really have a textbook, but we do have, is we use the Machinery's Handbook. It's a reference book, and I treat it sort of like a text in that we reference it constantly. So this is the little book that they have. Some of you, if you're engineers or work in industry, may have seen the green version, which is much bigger. This is a small pocket version, but this is what the students use for their reference. And there's all sorts of things. I teach them weekly different things that we find, that we come up across, that we need to find answers to, that are in that book. So we use it as we go, and I encourage them to look at it. Some of them have gotten pretty good at finding things in that book and are starting to get used to using it, and they're actually enjoying all the cool stuff that they find in there. So that's, anyway, that's my presentation on this. And again, the manufacturing program is, and you can see behind me here, there's a robotic arm, by the way, right over here. One of the robotic arms, we have two of them in the classroom. That one's been, the one behind me's been programmed to do some things, so it has some programming in it. The other one is just out of the box. It hasn't been programmed yet. The students haven't got that far yet, but there's also, what you can't see off camera here, are some nice NC machines, and the lathe is, the NC lathe is the favorite. The kids seem to like that one. It's good for doing some smaller things that we've had to do. We have an engine lathe, which frankly, for the smaller stuff is way too big, but when we get into some bigger machine parts, that engine lathe should be really nice. The engine lathe is manual. The NC lathe is numerically controlled, hence the NC. And we have an NC mill next to it, and we also have a manual mill that the kids really like across from me on the other side of the room. So we have some 3D printers. We have CAD. So students have a pretty well-equipped room. We can also do work-based learning projects with other classes as well. So if there's other technology or other tools in other rooms that they need, or other assistance, we can do that too. So anyway, I'll just wrap up. Like I said, if you have any questions, contact me at jmordell@btboces.org. And I thank you for your time, and please consider enrolling your children in this class. I think they will love this class, even if they're not necessarily going into engineering or manufacturing, but they might be in something similar, or someday they might morph into an engineering type program, even if they're in IT or something like that. If those interests, we actually have a project going on right now with one of the IT students and one of my students, demonstrating virtual reality, that Oculus system that's getting popular now. These kids understand it. We're going to do more presentations. They've done 2 demos already. And technology like that's up and coming is part of this program too. We try to integrate as much as we can in a way that makes sense. So again, like I said, I'm always available to talk after school, or even sometimes in the middle of the day between classes. If you catch me, I'd be more than glad to answer any questions you have about the program, or about any of the machines, or anything that I might be teaching the kids. So please, again, my name is Mr. Mordell, Jim Mordell, and I'm a manufacturing teacher, and I would love to hear from you. Thank you for your time. Goodbye.